So network layer is majorly focused on getting packets from the source to the destination, routing, error handling, and congestion control. Popular types of adaptive routing algorithm: one is centralized algorithm, isolated algorithm, and distributed algorithm. Suppose any problem in the data transmission between number of routers or number of devices, so it's going to handle different types of errors. Dear students, welcome to Computer Science classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. Students, let us start our discussion with the unit 2, that is data link layer. In this session, we are going to discuss the concept of function of one network layer and also routing algorithm. Now let us start with a network layer. So in voice reference model, so network layer is majorly focused on getting packets from the source to the destination, routing, error handling, and congestion control. See, these are the main functions of network layer. The first function is, so it's going to provide connection oriented service from host to destination or from source to the destination. And another function is routing, error handling. Suppose any problem in the data transmission between number of routers or number of devices, so it's going to handle different types of errors. And also congestion control. So if at all any problem with the network congestion because of heavy traffic across the network, and it also address this concept here. So these are the main functions or responsibility of network layer in OSI reference model. So another next function is addressing. What is addressing here? It maintains the addresses at the frame header of both source and destination and perform addressing to detect the various devices in the network. So if we talk about the addressing here, this network layer, it also maintains the addresses of different hardware and network devices in a network. So it's going to address different type of devices in a network. It is from source as well as destination computers. And next one is packetting. So here this is performed by there's IP protocol or internet protocol. So the network layer converts the packet from its upper layer. So actually the network layer, it receives the data from the upper layer and convert the packet from its upper layer. So it's going to convert the data packets received from the upper layer. Next, routing. What is routing here? It is the most important functionality. So the network layer chooses the most relevant and best path for the data transmission from source to destination. So this is one of the important function of network layer. So it's going to decide the best path between the source and destination. So in a network, it is possible to have more than one path between the host and destination. So the network layer is responsible for selecting or optimizing the best path between the source and destination. That is the meaning of routing here. Next, internetworking works to deliver a logical connection across multiple devices. So it is going to work with a internetworking connectivity or communication between different types of networks or with the multiple networks. See, these are all different functions of network layer in OSI reference model. Now in the next slide, we will see about network layer. Though the network or transport layer interface, the network layer transfers its services to the transport layer. So this is another, it's going to provide services to the transport layer. Now packets are termed as a datagram and corresponding subnet as a datagram subnet. So here, as we have seen, we are going to call the data in different name with different layers. So in network layer, the data are termed as datagrams. And to use a connection-oriented service, first we establish a connection, use it and then release it. In connection-oriented service, the data packets are delivered to the receiver in the same order in which they have been sent by the user. So this is another important function of network layer. So first of all, it's going to provide connection-oriented service, means it's going to provide a guaranteed delivery of data to the receiver. It means connection-oriented service. The meaning is, first, it has to establish a connection. So first of all, a session has to be established, or a connection has to be established between the sender and the receiver, or host and the destination. Then after establishing a connection, then it transmits the data and releases and once the data has been reached or delivered to the destination, is going to release that particular session or the connection oriented service. Now in connections in oriented service, the data packets are delivered to the receiver in the same way as how it has been sent from the sender. So this is the very important here. So whatever the data in the same format sent from the receiver, so it reaches or it delivered to the destination or receiver end without any change in the format. This is another important function of network layer. In the next slide, see what is routing. See what is the concept of a routing here. A routing algorithm. It is a procedure that lays down the route or path to transfer data packets from source to the destination. So what is the meaning of routing here? So you know a network device called router. So the network device called router, it is going to have or is going to prepare its own routing table in the network. So each and every router in a network is going to have its own routing table. So in the routing table, it's going to have it is going to lay down the route or path between the host and destination to transfer the data. So in the routing table, it consists of all the number of paths available to reach the destination. So all the details will be stored in a routing table of each and every router in a network, and they help in directing the internet traffic efficiently for efficient management of data traffic. After a data packet leaves its source, it can choose among the many different paths to reach the destination. If there are more than one path to reach the destination, so it is going to take the best path, the nearest path based on this configuration to reach the destination. And routing algorithm mathematically computes the best path, that is the least cost path that the packets can be routed. Here we are going to decide the best path in the routing table based on least cost path. So based on this concept, is going to decide the best path between the source and destination. In the next slide, we will see different types of routing algorithm. So here there are three types generally. One is adaptive routing algorithm, and non-adaptive routing algorithm, and hybrid routing algorithm. So in adaptive routing algorithm, we have isolated, centralized, and distributed algorithm. And in non-adaptive, we have flooding and random walk. And in hybrid routing algorithm, there are two categories, link stage and distance vector algorithm. In the next slide, we will see what are the adaptive routing algorithm. Adaptive routing algorithm is also known as dynamic routing algorithm. It makes routing decisions dynamically depending upon the network condition. So what is adaptive routing algorithm? I am here. It is also known as a dynamic routing. It means a routing decision can be taken as and when it is required depending on this network condition. I mean, whatever the network conditions or a configuration is going to change depending on the network situation. It constructs the routing table depending upon the network traffic and topology. See, another advantage of this is the routing table at each and every router is prepared, or it is constructed based on the network traffic and network topology. So accordingly, it can change its routing table. That is the meaning of dynamic routing algorithm. And they try to compute the optimized route depending upon the hop count and transmit time and distance. And how is going to lay down the table or routing table? It is based on the factors like hop count. The hop count is nothing but number of devices it has to reach before reaching the destination. So next one is transmit time and also distance. Distance in terms of least cost path, what you have seen in the previous slide. And there are three popular types of adaptive routing algorithm. One is centralized algorithm, isolated algorithm, and distributed algorithm. In the next slide, we will see what are non-adaptive routing algorithms. So here in non-adaptive routing algorithms, it is also known as static routing algorithm, as we have seen in the previous slide. So here adaptive is a dynamic routing algorithm, but it is a static routing algorithm. It means it constructs a static routing table to determine the path through which the packets are to be sent. So it is once at the beginning, once it has been configured, or it's going to have its own routing table permanently at once. And there is no question of a dynamic concept here, or it is going to work with only one routing table configured at the beginning before data transmission. Next one is the static routing table is constructed based upon routing information stored in the routers when the network is booted up. So when the network is started booting up, by that time is going to have a routing table, that is a static routing table. And there are two types of algorithm. One is flooding and second one is random walk. These two are the different non-adaptive routing algorithms. In the next slide, we will see what is flooding. See, in flooding, when a data packet arrives at a router, it is sent to all the outgoing links except the one it has been arrived on. Now look at the example here. So here we have A, B, C, D, E and F. These are all nothing but routers, a network device. So this is a network. In this network, we have number of routers. So here, when the data packet arrives at a router, for example, when a data packet arrives at A, for example, this is an example here. So when data packet arrives at A, is going to transmit the packets to all the devices in a network, except for A, which has been received from the network. So here, except that one has been arrived on. So in this example. Next, flooding may be uncontrolled and controlled or selective flooding. So this is called flooding here. What is the meaning of flooding in this example? Any data which has been received at a router A, it has been transmitted to different nodes in a network or different devices in a network. So there are three types. One is unconditional, uncontrolled or unconditional. One is controlled and selective flooding. See, these are all the different methods of flooding. Next one is using flooding technique. Look at the example here. In this example, an incoming packet A will be sent to, now for example, consider that any incoming packet from a network which has reached the router A. In this example, then the packet will be sent to B, C, D. So the same packet will be transferred to one B, C, D, which are immediately connected nodes here. Then after again the B will send the packets to C and E because B is connected to E and C directly. So in this example, as it has been received from the packet from the A, it will send the data packets which has been received from A to E as well as C. Then again, C will send the packets to B, D, F. So C already which has been received the packet from C, now B as well as D. So it's going to transmit the packets from C to D and F and as well as to B. Next one is D will send the packets to C and F. Now look at the D, which has been received the packet from A already. So again from C. So it will send the packet to C and F. See, this is C, as well as one more node here is F. It will send the packets to F. And again, E will send the packets to F. This is the E, will send the packets to F, and for E, it has received the packet from B. And F will send the packets to C, and again, F will send the packets to C as well as E. So this is how. So if you observe, this is called a concept of flooding here. So what's the drawback of the flooding? If you observed here, so here all the routers, all the devices will transmit the packets to each and every devices in a network, or we can say that each and every devices will be received a multiple copies of the same packets. See, that is the main drawback of the concept of flooding here. So this is the concept of flooding, where the packets which are received from the network to one particular node, it has to be transmitted to all other nodes in a network. Here there are chances of multiple packets in a network. It leads to network congestion. In the next slide, we will see what are different types of flooding, what you have seen in the previous slide. One is uncontrolled flooding. So here each router unconditionally transmit the incoming data packet to all its neighbors. So here uncontrolled flooding. So any router unconditionally transferred to the all its neighbors. For example, in the example, suppose A is immediate neighbor is here D, C and B. So any data, incoming data to A will transmit to the all other neighboring devices unconditionally, means continuously. Now, if we talk about in controlled flooding, another type of flooding here, they use some methods to control the transmission of packets to the neighboring nodes. So, in this example, it has some other technique so that it's going to avoid transmitting all the packets to the neighboring nodes. Now, selective flooding. In the selective flooding, the routers don't transmit the incoming packets only along those paths which are heading towards approximately in the right direction instead of every available path. So, if you look, what's the meaning of selective flooding here? Whatever the data packet which has been received at one particular router or one particular device, it will not be transmitted to all the nodes in a network, and it will transmit it to only limited nodes which are heading forwards. That is the concept of in selective flooding here. Now, there are two popular algorithms for controlled flooding. One is sequence number controlled flooding, SNCF, or reverse path forwarding, or RPF. These are all the different algorithms under controlled flooding. Students, in this session so far we discussed about the network layer and its responsibility or functions, along with the concept of routing. We will continue our discussion in my next class. Thank you very much.